All right. So this first thing is just copy and pasted from what we did before. I changed it a little bit, but I'm not going to really go into that. I changed step 4, the wording a little bit, then once on yours. But we did this before, step 1 and 2. We've been doing those so far. The only difference is, like I said, once you get over step 1 and 2, you still have step 3 and 4. If there's a number in front, you have to do those extra 2 steps. Technically, you do those steps anyways if there's not a leading coefficient. It's just that step 3 is you're dividing your numbers by that first number. Well, if your first number is 1, dividing by 1 doesn't really do much. And then step 4, make sure you're getting rid of your fractions. So let's go ahead and get started with this. Now again, the big thing, a lot of people that make mistakes on this, the biggest mistake is right away they say that this is 12. And I know I've said this 3 or 4 times, but it's what a lot of people do. You're not taking your last number, it's your first number times your last number. The reason that it seemed like that before is when your first number is 1, 1 times your last number is just going to be your last number. So 5 times 12 is 60. Then my bottom number is 19. Now again, the reason I like this method is because if you already know what 2 numbers multiply to be 60 that add up to be 19, you can put those in and you can move on. That's great. But if you don't, just keep going and list those factors. For these problems, you can do as much or as little as you want, kind of. So factors of 60, and if you pay attention, you can you might not have to list all of them. We're looking for ones that add up to be 19, so 1 and 60. 2 and 30, 3 and 20, 4 and 15. So we could stop there. 4 and 15, that adds up to be 19. You can be done if you're paying attention to that. I usually list all of them just because I kind of have to do one thing at a time. I can't multitask very well, which you guys probably already knew about me. So which ones add up to be 19? We already said was the 4 and the 15. Again, double check. Positive 4 times positive 15 is 60. That's great. 4 plus 15 is 19. And again, I know that one seems pretty straightforward. It is because they're all plus. So the second thing a lot of people miss, and I know I mentioned this earlier as well, they leave their answer x plus 4, x plus 15. If there was not a leading coefficient, you would be right on track. But there is a leading coefficient. So once you have that listed down, step 3 is where you divide these. So I divide both of these by your leading coefficient, so I divide both of these by 5. If they reduce, make sure you reduce them. And I have an example, number 3, I actually changed from what yours says, and I'll talk about that when you get there. But if you can reduce, you need to reduce those, even if they end up getting you another fraction. If they don't reduce, like this first one, or once you have reduced, move that denominator up in front of your x. This is actually 5x plus 4. 15 divided by 5 reduces as x plus 3. Those are the only 2 extra steps. Now, I will tell you, I really like this method. I think this is the easiest method. I have not been able to teach this method for the last 6 years because when I worked at Goshen, a lot of the math teachers, all the math teachers, said, well, we don't like this method because it's just a trick. They literally would poke fun at other schools because it's like, well, you guys don't actually know how we factored or why that is. Here's the deal. If those of you who are going on to pre-calculus and calculus and beyond, you'll eventually learn why we do this. Those of you who aren't going to pre-calculus will never have to actually know how you're doing this. But there was a lot of things in math that never actually clicked why I do it until I got to college. Last but not least, before we move on, you could take a lot of time and you could actually multiply this out to make sure you end up with this answer. 5x times x is 5x squared. 5x times 3 is 15x. 4 times x is 4x. 4 times 3 is 12. Combine your like terms, you should get what you started with. If you want to check your work, that's the best way to do it. Hypothetically, you can tell me if you got it right or wrong when you hand it in. However, a really quick way that doesn't say necessarily that you're right, but if you're on the right track, just take your 5x times x, just your first two numbers, that should be 5x squared. That should be what you have. If you end up with 5x and 2x, that's 10x squared. That's not what you have, so you definitely know you're wrong. But it's not a bad idea. With these that have leading coefficients, it's not a bad idea just to take that little double check. Moving on to 2, now we have a minus, so it does get a little bit more difficult. So 3 times 12 is 36. Factors of 36 that add up to be negative 20. It's positive 36, keep that in mind. 1 and 36, 2 and 18, 3 and 12, 4 doesn't work, 5 doesn't work, oops, 6 and 6. So we want them to add up to negative 20. 2 and 18 almost do, but they add up to be positive 20. So remember, all you need to do is switch your signs. Both of them, switch both, so they're both negative now. And again, if you double check, negative 2 times negative 18 is positive 36. Negative 2 plus negative 18 is negative 20. You end up with x minus 2, x minus 18. Some of you are going to miss this because you leave it there, but we still have to divide everything by 3. So if it doesn't reduce, go ahead and put that 3 up with the x. 18 divided by 3 is 6, so x minus 6. And again, if you double check, 3x times x is 3x squared. That's what we have, so we are on the right track. Again, that doesn't mean you necessarily got it all right, but you can at least tell you can tell if you got it wrong, I should say. Any questions on this so far? I know the meat and potatoes of this is the same thing you've done before, or at least I think so. And again, if you don't like the X method, I don't care. You can do it a different way. That's fine. Try to share your work if you can. But I like that X method because it's really good to check your work. So number 3, I changed my number 3. So you're going to want to do the same thing, and I'll tell you why once we get started here. I changed this to 4x squared minus 4x minus 15. I think. So make sure you write this one down, or else you're going to have the wrong work, and it might confuse you later. 4x squared minus 4x minus 15 for this one. So you start doing everything the same. 4 times negative 15 is negative 60, I believe. And we want numbers that add up to be negative 4. So factors of negative 60, remember it's negative, so I'm going to make my left-hand side negative. So we're looking for numbers that add up to be negative 4. So I have all my factors of 60 listed. And again, I know there's a lot of them, but it's not that hard to find. You just got to keep going. So again, just like we did on the last one, negative 6 and 10 work, but that gives you positive 4, not negative. So remember, all you have to do, go back and change both of your signs. So positive 6, negative 10. And again, take this time to double check. 6 times negative 10 is negative 60. 6 plus negative 10 is negative 4. Someone's going to miss one of these, and I'm going to circle that, and I'm going to say 6 times 5 does not equal negative 60 or something like that. So we have x plus 6, x minus 10. So here's the problem with this. So far, so good. Divide both of them by 4. These fractions don't divide nice and evenly. So earlier when we did all these other problems, if your fraction, if you couldn't divide nice and evenly, you just put your denominator in front. If you could divide nice and evenly, negative 18 divided by 3 was 6, so you put that in there. If you can't divide nice and evenly, you still have to reduce. If you just put this 4 in front, you put this 4 in front, that's not going to work. You can tell, because 4x times 4x is 16x squared, not 4x squared. So you have to make sure you reduce. So x plus, let me erase that, make it a little bit bigger, or move it up. X plus 3 over 2, x minus 5 over 2. Once they are reduced, now you can move them around wherever you need. So the 2 goes up with the x, this 2 goes with the x. You end up with 2x plus 3 and 2x minus 5. But I wanted to make sure I showed you that because that's the only one in the notes that you ended up reducing your fractions, and you still had to get rid of that denominator. And last but not least, 2 times negative 9 is negative 18. That adds up to be 3. You need to list these out. Negative 1 and 18, negative 2 and 9, negative 3 and 6. Negative 3 and 6 are the ones you want. They do add up to be positive 3, so you don't have to worry about changing signs for anything. Negative 3, positive 6. And again, to double check that, you can confirm. Negative 3 times positive 6 is negative 18. Negative 3 plus 6 is positive 3. So we have x minus 3, x plus 6. Divide both of them by 2. Move the 2 up because that's already reduced. And 6 divided by 2 is 3. Now again, I'm hoping this is starting to get pretty boring because you're doing the same thing every time, but that's the idea. I want you guys to get good at this. I want it to be in your muscle memory. Last but not least, again, if you look over here, I know that these signs are going to be different for number 3 because it's a minus. I know these signs for number 4 are going to be different because it's minus. Problems 1 and 2 are going to be the same because it's plus. But again, like I said, the good news is you don't have to worry about that at all if you stick with using your signs correctly. So if you make sure we have a negative 16 and a negative 4, a negative 18 and a positive 3. Because if you do it that way, it's going to work out in the wash. You just have to make sure you're careful. Make sure you're double checking that.